Hi there. So I promised that the last video will be the actual last video on this topic of placing single buildings in parcels, but I think I want to show you one very tiny little addition to it. So in this fourth video, I just want to show you how to select some parcels to become parks and not to place any buildings there. So basically the idea is very simple. The idea follows the same pattern as we had here when we were filtering parcels based on their size. But the idea is exactly the same. We want to check whether the parcel is too large, small, um, tiny, or maybe it is closer than some given threshold distance to the attractor which we manually place, and we just want to filter this parcel out. So let me show how to do it. For this, you should either select to work right here before your final part of this building placement script. So when you already have your parcels generated, so you might want to select some of them somehow manually with points or lines and convert them into smaller parks. Or as in my case, I want to go even more to the left to my city blocks. And now I want to be able to select city blocks right here and use some of them as green spaces. So again, I want to give some space for new components. And right here, I want to build a small call pattern sequence. So yes, I will use a call pattern. Um, I need to check, well, I'm not sure. I want to probably use points to indicate which parcels I want, or which city blocks I want to preserve for green spaces. So I could either use the point um, input, which is the simple point data container data component, and here I can select set one point and either select some point from Rhino or change the point. Change the type of this point from point to coordinate, and in this way, you can now place any point right from your grasshopper, and then if you deselect and select the component again, you can actually move it without the need to store this point in Rhino. But in my case, I want to create a new layer in Rhino and be able to place anything on this layer, any points, and I want all these points to be considered for decision on making street blocks green spaces. So I'm creating a new um, layer. I will call it green areas. And I will place some points here. So I'll type point in Rhino and maybe place a point here, um, here, here on the other side of the road, and maybe here. Now, how do I get all the points from this layer in Grasshopper? For this, I can use the geometry pipeline. This is how it looks like, geometry pipeline. And in this dynamic component, you can enter the layer name by double-clicking this star icon here and entering something like green areas. Enter. And I also need to select the type of geometry to reference from this layer. So in my case, these are points, so I double-click on the points. I do not provide any name because I simply want all objects to be referenced. Now let me create data component connected here, and I don't see any result here. This is funny. Oh yeah, I think because I placed my points on the default layer. So as you can see, I did not select green layer, green areas layer as my default, as my current layer. So you can normally do it by double clicking. I did not do it, so all of my points are now on the default layer. I need to select them and move them to green areas. I can do it by going to the lower part of Rhino and selecting default and changing it to green areas. So this will move currently selected objects to another layer. And now you can see that my points are actually referenced in Grasshopper and I can use them. How do I use them? I want to check whether any of these points is inside the city block. And if yes, I want to filter out the city block and use it for green spaces later. So I will use the point in curve component. Point in curve, yes. Test the point for closed curve containment. So my points are the points I have just referenced, and my curves are the city blocks. Now, pay attention that you have to do something with your inputs. You have to graft one of them. Otherwise, if this component receives two lists of different size, it will not behave correctly. So I aim to check whether at least one point of these four currently referenced points is inside the city block. So I will means that I need to structure my data um, based on the parcel and not based on the point. So for every parcel, I want to check all the points, and I want this information stored locally in one branch. So I will graft my C input of point and curve, and so the output will have the structure of 37 branches, the same number as I have my city blocks here, and each branch will have multiple elements, in my case, four elements, um, indicating the relationship between the point and the curve um, for these 4 points and every single one of the parcels. Also, if you hover over this R output relationship, you will see how it is stored. So it can be either 0, which means the point is outside of the curve. It can be 1, meaning the point is coincident, so it is on the curve itself, or 2, meaning the point is inside the curve. Now, I need to check whether at least one of these four elements in each branch is 2. So whether at least some points I have placed in this layer are inside the current city block. The easiest way to do it is to sum up all the numbers. Because if all of them are zeros, the addition of zeros will give us a 0. If at least one of these numbers is positive, so meaning it is either 1 or 2, it means that at least one of the points is actually inside. So what I tend to do in these cases is to use that mass addition component. This is the default Grasshopper component, which allows you to just sum up all the numbers inside each individual branch if you have multiple branches. So if I check the output, this will be just a single number per branch, and this number will indicate whether there were some points inside the current city block, and then you will have a positive number, probably 2, or whether none of this point is inside. And in this case, you have a 0. And now I can convert this output to Boolean. You don't actually have to do it. Grasshopper will do it automatically, but just do it so that you understand better how it works. And converting numbers to Boolean means that all 0 numbers will be converted to false, and all positive numbers will be converted to true. And this is exactly what we want for our call pattern. And now I can connect it to the P input of call pattern. So this will be the pattern which will decide which city blocks to filter out and which not. I also need to flatten it, of course, because I don't, my city blocks are stored in a list, so I also don't want to impose any data branch structure simply because of this simple operation. And now I need to connect my city blocks to the call pattern since I want to filter city blocks out. And as you see in my Rhino, I indeed got my city block selected based on the point containment. The only thing is that I want to invert the P input because I want to filter out those green spaces, and all other city blocks I want to retain. And this was it, actually. So I can now restructure my file a bit. As you can see, I really love to do it. uh, so that it all remains at least partially understandable. Yes, so this is what I want to do. I want to use the output of cal pattern for my later offset to generate some minor streets. And in the end, if I scroll all the way to the right, or if I actually just deselect my um, preview of only selected objects, you can see how the points I have placed now affect the result. Um, Also, to actually make these spaces green, you somehow need to get them right, so that you can provide some color for them. And to do it, you can simply copy this cal pattern, and in this second copy of it, you do not need to invert the pattern. And in this way, here you will get your city blocks, which are supposed to be parks. And in the later video on visualization, I will show you how to add some colors to it. But for now, I will just spare some time by connecting it to a new data container and call it green areas. That's it. Yeah, this was a small addition I wanted to show you, and see you in the next video.